the sequence number here and acknowledgement on both sides, because remember, we got two-way communication here, yes, but this is PC1 sending out his first piece of data. Here's PC2 sending out his first piece of data. The first piece of data he sent was sequence 2. So let's take a look at this. PC1 is going to send out a sequence number of 100. It's going to come over here to PC2. PC2 is going to acknowledge the fact that he got the sequence number, the data with the sequence number of 101 by sending an acknowledgement of 102. However, PC2 has data to send as well. He's going to send a piece of data with sequence number 200. So now, this data comes over to here. PC1 will get data with a sequence of 200 and an acknowledgement of 101. So what does that mean? That means now PC2 says, okay, I got an acknowledgement of 101 from PC2, which means that he got my data with the sequence number of 100. Therefore, I am going to send my next sequence, my next data with the sequence number of 101. And I'm also going to acknowledge that I got PC2 data with sequence number 200 by sending him an acknowledgement of 201. And this is where it gets a little confusing, because you're just like, I'm kind of lost here. So when you start looking at this data here, you notice that these reds deal with PC1, and these oranges deal with PC2. And this is how it's sent. So here we have data going this way, acknowledgement coming back, but then you have, data sitting here writing on this. Then you have data going this way. So as you can see, the data, as we're leaving, will be here. And as the data is sitting here, attached to this bad boy, as it's coming back. But this is PC2's data. What's in the orange, and what's in the red is PC1's data. And that's how sequence numbers works, which is pretty cool. And that's how your data is guaranteed. So now let's look at windowing along with the sequence numbers. Interesting. Starts to get a little even bigger, right? Now, one of the things that I did not mention, which I'm going to mention here, is what happens when you get the wrong sequence number back or the wrong acknowledgement back. And that's what we're going to look at right here. So I'm going to send one piece of data. Boom. I'm coming over here with a sequence of 100. I'm going to send back an acknowledgement of 101. Telling PC1 that, hey, PC2 must have gotten the data that I had attached to sequence number 100 because he's sending me an acknowledgement of 101. He's expecting to see 101 next. So I send him the sequence number of 101, which is here. And then I'm also going to send some data with 102 on here. This is windowing doing his job. He's starting to send more data. So PC2 sends an acknowledgement back of what? 103. Well, that makes sense because he got sequence number 1 and 2, 101 and 102. He's expecting to see 103 next. That comes over to here. Now I'm going to send 103, but Windows going to say I'm going to try 4 and 5. Now this is an interesting thing. If he's sending 5, what is PC supposed to be sending back to him? 106. But he's not. He's sending 105. Huh. What does that tell PC? 1. If PC1 sent 105, 104, 103, PC2 should be saying that I'm going to acknowledge you with a 106. But he doesn't. PC1 gets something back, an acknowledgement back with 105. That's telling PC1 that, well, wait a minute, I already sent you 105, which means you're not getting 105, which means we got a communication issue here. So at this point, I'm going to lower my window size, and I'm going to resend 105. And when I resend 105, what am I really sending? The same data I sent with 105. I'm resending that data. And I'm going to put that 105 back on there. Well, I don't know exactly. We'll put the exact same 105 on there. It's been a while since I've gone through this with Wireshark to really see how this data moves across. It might use the same secret number, or it might just continue on with the secret numbers that's next in line and resend that data. Again, this is really meant for you to understand how this is happening. Not to be 100% accurate. These are the labs you need to be doing yourself to find out what's really the truth. So my window sizes are going to shorten, and now I'm going to send 105 and 106. Now notice I'm sending the exact amount of data here, even though on this line, I'm sending the same amount of data on this line that I was on this line, even though we dropped the packet and it didn't get sent over. So really, technically, it wouldn't be just one that we wouldn't be sending. It will be two of them that we would not be sending. Which means I'm going to go back to where I know my numbers were accurate. If I sent 3 at a time and I dropped one, why would I send 3 again? I wouldn't. I'm going to send 2. I'm going to shorten my window size. And this is how it all works together, man. This is how your sequence number, your acknowledgement numbers, and your windowing all work together. And it's a beautiful, beautiful concept. And that's how we get guaranteed delivery. Multiplexing is a concept of nothing major. I like to talk about it just briefly. And we'll read what this says up here. The ability to transport different types of data and use port numbers to let the destination host know where the data goes. That's really the concept of multiplexing. That we can have more than one type of data transferring on the same media. Awesome. Which means on my Ethernet, I can run TFTP, HTTP, SNMP, all on the same wire. And what separates that traffic though? How do I know it's HTTP traffic? How do I know this? Oh, by the port number. And this is the concept of multiplexing. Another powerful thing of port numbers. Because when this server saying data's coming in, and let's say we have these nice little queues. HTTP, all's going to go up to here. We kind of got this flow of data coming in, right? We'll say you got these nice little, all this data coming in. And you have this checkpoint, right? This is something I'm just drawing right now. This is not something that's actually accurate. And you got this checkpoint. And at some point, you got this guard sitting here and say, oh, okay, here comes this piece of data. Let's grab this one. Let's take a look at the port number. Oh, your HTTP traffic? Let's throw you through here. Boom. And it's just kind of like this. I think about Men in Black when you had that alien inside the box that was sorting the mail with all those arms. If you haven't seen that movie, I apologize. But that's pretty much what this is. It's grabbing the data real quick, looking at the port number, throw it down, throw it down, throw it down, throw it down. All done by port numbers. This is what we call multiplexing. Because you're able to send multiple protocols down the same media without having all these different types of media and all these different types of protocols to monitor the protocols. Does that make sense? All you have to do is have services on the clients and the servers to listen in on those ports. So let's talk about port numbers. Port numbers are nice because, like I said, with multiplexing, we can use port numbers as a means of listening and sending traffic out. Remember I talked about port numbers were the doors to get through to things. We can use a firewall to shut those doors, keep them all shut, and only allow the traffic that are coming through. Or we can just go on our PC and say, I'm not allowing this traffic. And you would go in there and shut down those ports. And it would no longer be listening on those ports. It's a powerful tool to use. So now, if PC 1 is sitting over here, communicating with PC2, and he sends the data out. Here's our data. On top of that data, we're going to have layer 4. We're going to build it as if we were looking at the OSI model. That layer 4 is going to have a source port, we're going to say, of 19. And a destination port of 50. I'm going to build my layer 3 information, which is going to have my source IP, which is the IP address of PC1, and the destination IP. I'm going to have my layer 2 information, which is going to have my source MAC and my destination MAC. Man, it's starting to look like the OSI model, isn't it? And here's layer 1. Right? Not really. Because if we're going up in this direction, layer 1 shouldn't be down there. Because after all this is built out, it gets put on the wire. So layer 1 belongs up here. So here's our data. We got 4, 3, 2, 1. Layer 4, 3, 2, 1. That information gets built and goes out what? The PC. Hits the switch, hits the router, switch, comes back over to PC. Now the PC is going to get the data coming in on layer 1, coming in on layer 1 as electrical signal. And what is he going to see when it's coming in? He's going to see the source MAC and the destination MAC. If that information belongs to him, the destination MAC, if that's his MAC, he's then going to see the source IP because he's going to remove the layer 2 information and look at the destination IP. After that, we come into here, and what are we going to see? The source port and the destination port. And then, here's our data. Now, if we do this way, we have what? Layer 1, layer 2, layer 3, layer 4. Why do I keep repeating this? Because it's important for you to know. It really is. Beyond CCNA, you need to know how this works. But nonetheless, this part right here, this port number, this layer 4 information, man, this is important. And I mean really important to know, because what happens if anywhere down the path this port number is not allowed? I want you to think about that. If I'm sitting here on this router and you have a deny for port 19 or port 50, I want you to think about what's going to happen here. First, we're going to deny port 19. That's the first thing we're going to deny. So this traffic goes through, and guys, it doesn't matter in which direction. Think about it. It doesn't matter if I'm denying it going in this direction, or out this direction, or out this direction. Okay? Because as the traffic is going in this direction, if I am blocking 19 from coming in on this router, which is router 1, guess what? We're pretty much done, right? Because that traffic is going to be blocked. Now you got to ask yourself, well, wait a minute, Kyle. We use layer 3 to build our information. Yeah, you sure do. Yes, you do. But does routers work on layer 4? I thought it only worked on layer 5. Well, I mean, layer 3. That doesn't make any sense to me. Well, let's take a look real quick. Let's go into this router here. And let's find this. Let's actually do an access list. I'm going to create an access list, and I'm going to say extended. Oh, I need to say IP access list. Sorry, IP access list. And now we say extended. I was wondering why it wasn't working. Extended, and we'll just give it a name of Kyle. Doesn't really matter. What I want to see here is the output that I get. And I'm going to say deny TCP. Wow. TCP is actually there. I can deny TCP? Well, let's find out. TCP, and we're not going to do it in a real lab. We're just going to see if the command, what commands we have in there. I'm going to say from the source 1.1.1.1 to, and we'll do the wildcard here, and we'll say equal. What does this mean? Match any packets with a given port number. Port number 50. Look at this. We have another port number we can put in. We can have host names. Or we can have a destination address. So I'm not going to put in another port number. I can put in many port numbers as I want here. I'm just going to go to a destination address. And we'll say 2.2.2.2. Destination bits. And I also can say, also, equal to port number. What was the port number we're using? Port number. I'm going to move this out of the way. Oh, there it is. 19 and 50. I had it in the inside the header information. And we're going to say 219. And we're done. Now look at that command I just created. We're going to highlight this command and we're going to shut this down. This is the command I put on the router. So that shows you, man, that I can actually look at the layer 4 information of a router if I want to. For some reason, people believe that a router could only look at the layer 3 and that's it. It can't go any deeper. But it shows you right there, I can create an access list. I can create a rule saying I want to deny TCP traffic now. Which means what? What is it going to be looking for? What do you think it's going to be looking for? You're absolutely right. It's going to be looking for the IP header information. Not the IP header, I'm sorry, the TCP header. If it's a UDP header, it's not going to be focusing on that type of traffic. But when it opens up that layer 3 information, looks at that layer 4, and it sees its TCP information, it's going to say, oh, that's TCP. Before I forward it on, let me check and see if it's allowed. Because I'm denying anything that's being sourced from 1.1.1.1 that is equal to port 50 and being sent to 2.2.2.2 and equal to port 19. This is pretty great.